Hey everyone! Welcome back to the channel. Today, we're delving into the exciting realm of data processing with two libraries, Pandas and Polars. Whether you are a data enthusiast, a developer, or just someone curious about efficiently handling large datasets, this video is tailor-made for you. We're putting two powerful Python libraries to the test, the ever-popular Pandas and the up-and-coming challenger Polars. Pandas has been the go-to for data manipulation for years, but Polars is making waves with promises of lightning-fast performance. So let's see how they stack up. Pandas is a well-loved library in the Python ecosystem. It's incredibly versatile, user-friendly, and perfect for handling small to medium-sized datasets. But when the data grows, its performance can start to lag. Enter Polars. Built on the Arrow memory format, Polars is designed for speed and efficiency. It boasts parallel processing capabilities, making it a fantastic option for big data tasks. But does it live up to the hype? Now let us compare traditional and lazy API approach. Imagine you're a chef in a busy kitchen with a big order. You write down each step of the recipe one by one like writing code. You immediately grab all the ingredients you might need for the entire recipe, like loading all data into memory. You follow the recipe step by step, preparing each part like executing each line of code. This can be slow and overwhelming, especially if you have a big order, like a large dataset. This concept, eager execution, is similar to using a traditional library like Pandas with large datasets. Now let us understand lazy API or Polar in current context. You tell your assistant which dishes you want to cook. It can be understood as define operations. The assistant skims the book, figuring out the most efficient way to prepare everything. This is similar to optimize operations. They only copy the relevant parts for the current dish. It is like the loading of only necessary data. Once a dish is planned, they move on to the next, copying only what's needed. It is like a delayed execution. So from this example, we can see that the lazy API, or delayed execution, lets you define what you want to do with the data without immediately processing everything. This can significantly improve performance, especially for large datasets. First, we need to install necessary libraries. Also, in some cases, we should upgrade Polars to its most recent version. We'll create two datasets, a large one with 10 million rows and a small one with 1,000 rows. This will help us see how each library performs under different conditions. First, we will code to generate our datasets. We'll save them as CSV files for both our large and small datasets. Then we will measure how long it takes for Pandas and Polars to read, process, and aggregate these datasets. So let us proceed.
So first thing we need to do here is we need to install this Polar library. So command is very simple, pip install polars. I already have Polar installed here, so I need not to, but you can install if you don't have. Another thing is I'm using this Google Colab interface for running my program. So there is no foundation. You can use Anaconda, Jupyter Notebook, or any other method to run this program. Okay, so what is next? We need to import different libraries. First thing, import Pandas as PD, because we need to compare performance of Pandas versus Polars. Then NumPy, we need to import this NumPy library. And then finally, import time. The reason we are importing time, because we have to compare what time we are consuming when we are dealing with large data set here. Like here, you can see that number of rows here are 10 million, and for the small data set, 1,000 rows. So that's why I want to do comparison of the timing. The next thing is the function. So this function is we are synthesizing that data set. We may have option to use our own CSV file. We can directly read. We can just upload here, and then we can just play with that. So this is another way to deal. But here I'm just using this function to create our own CSV file. So that CSV file, what we are doing first, np.random.seed 0. That means this particular line, if we'll rerun this file somewhere else with the same command, we'll get same random number. Okay, so A is first column for that data frame, where we are getting a different random value between 0 to 100 and integer, and the for another one will get some float value like 0.46, 0.6, 0.8, something like that. And the third column is C, where a different value X, Y, and Z from this dictionary will be selected randomly and will place for that C column element. It may, like, first element will be X, maybe next element will see Y, next element will again see X, completely random. Okay. And then this data frame, we can see that from PD, Pandas will create this data frame, and then we'll convert that data frame into a CSV file. And then finally, you can see there is a variable number rows. In one case, this number of rows are 10 million. In another case, this is 1000 for comparison. Okay. And the next thing, what we are doing, we are creating another function to measure performance. We want to measure to compare both pandas and polar. That is one comparison. And another comparison is for the time. Time means like pandas and polar is okay. Time is what time we are taking for doing this calculation. And next comparison is for the large and small data set, because we need to know that for which purpose, for which type of data pandas is better, and for which segment we should use polar library. Okay, so polars versus panda. This is the sort of function for performance measurement. So first, what we are doing here, so the start time dot time, so that is we are initiating time, and then this df underscore pandas, this d, we are making another column where we are multiplying column A multiplied by column B. So element to element multiplication we are doing. Okay, so let us understand what we are doing. So suppose we do have this column A, column B, and column C. Column A, for example, suppose first element is 2. Okay, and column B, suppose first element is 0.5, and column C is like it may have some random value. Say random value is X, because remember this is first here you can see column C is random choice X, Y, and Z from this dictionary. So first multiplication for D will be 2 multiplied by 0.5, so it will be 1. Okay, 2 multiplied by 0.5, 1, and that is X is mapped with 1. Okay, another next row, say for example it is 2, and for B it is 0.25. okay, so 2 multiplied by 0.25 will be 0.5. okay, and for C, suppose it is again X. Okay, so X, when we are doing this aggregate D as a sum, so that means we are counting for each X, Y, and Z. So for X value, what is going to happen? For first column it was 2 multiplied by 0.5 plus 1, and second one plus 2 multiplied by 0.25, so it is 0.5. So value will be 1 plus 0.5. So X, you'll see 1 plus 0.5, that means 1.5. So that we need to do for all like a million, 10 millions rows for X, Y, and Z, and then we'll do all that aggregation independently for X, Y, and Z. And then for pandas, we are calculating how much time consumed for this operation, and similarly time consumption for polars, we can see the same operation. Only difference you can see that here it is PD and here it is PN, because we are using polar library. And then everything you'll see moreover similar, moreover very much similar. Few change you will see that how we write code in pandas versus polar here, but moreover everything you'll see same. And then we are just printing out this result for performance. We are also printing group by pandas, like how much X, Y, and Z for this total summation for 10 million and 1000 rows. And then performance measurement, will see how much time it is consuming for pandas and polars. Okay, so let us quickly run this code and see what will be our output. Okay, so let us click here and we'll wait for a few seconds. So this calculation is over. So we can see the difference of this time. For pandas, time is 6 seconds, and polars it is approximately 2 seconds. So we can see a significant change in time. So Polars, they are very useful, it seems, at least for this particular set of calculation where I'm using 10 million versus 1000. So for the 10 million large data set, you can see that polars are highly useful. And then for this group by result, we can see our random distribution x, y, and z. It's almost uniform distribution and summation, and performance of pandas and polar, you can see moreover similar, moreover similar. Now, when we go for this small data set, pandas timing is 0.01 and polar's timing is 0.00. Obviously there will be, if we'll use some another unit, for example millisecond, you'll see some better comparison. But here also we can see there is not significant difference between pandas and polar. But for large data, definitely we can say that polars, they are much better.
So we can notice that Polars is a powerhouse for large-scale data processing, making it a fantastic tool for handling big data efficiently. Pandas, however, remains incredibly efficient for smaller datasets and quick analyses. But don't just take my word for it. Try it out yourself. Experiment with your own datasets, large and small, and let us know in the comments where you found Polars or Pandas to perform better. We'd love to hear your experiences.